Here's another form for the chain rule. It says if we want to find dy dx and we have an intermediate variable u, we can write dy dx equals dy du times du dx. It's a very nice, intuitive, easy to remember expression. Let's see how it's used in an example. Let's take an example where we have y as a function of u and u as a function of x. This is the perfect setup to use this type of a rule. We want to find dy dx. One way to do it would be to take this expression for u and substitute it in here and then differentiate with respect to x. But this gives us another alternative, and it's an important way to go about doing the problem. And it's also very easy. All we have to do to find dy dx is we find dy du, so we just differentiate u cubed plus 4u. Well, that's easy enough. Using the power rule, that's 3u squared plus 4. And then separately, as a separate problem, we find du dx. So we take u equals x squared plus 3x, we differentiate it, and using the power rule again, it's 2x plus 3. Now, all we have to do to find dy dx is to multiply these two things together. So we take 3u squared plus 4, that's the dy du, times du dx, which is 2x plus 3, and that is dy dx. Now, this is not totally in terms of x. Notice that there's still a u in the expression. So if we wanted to write this totally in terms of x, we would have to substitute in this value of u in order to get this final expression in terms of x. And that's easy enough to do. In for u, we put in x squared plus 3x. And so we have 3 times x squared plus 3x squared plus 4. That's this first term. And then we continue on with the last term, 2x plus 3. That's the du dx. So this is another form of the chain rule, and it's another notation that you'll need to know. And this is how it gets used.